So today we want to pull together a bunch of the different things that we've been talking about for the last couple of lessons, and we want to talk about solving polynomial functions. If you recall, if you have a factorable polynomial function, we want to solve by factoring. That is how we solve all polynomials. It's how we solved quadratics, which is just a degree 2 polynomial. And even linear factors, really, it's just that they just have one factor, so it's not nearly as exciting. But to solve polynomial functions, you want to factor it, and then we want to use that zero product property. That really is the driving force behind all of this. If two things multiply to equal 0, or if 5 things multiply to equal 0, one of those things has to be equal to 0. And so that's what this is talking about. If you can get the polynomial equal to 0 and then factor it, each of those factors, one of them has to be 0. And so we set them all equal to 0 and solve. And so the stuff that was on your last quiz and the stuff we've been working on for the past couple of days have been trying to get a polynomial in its most factored form, get it down so that it's all linear and quadratic factors. Because if we can factor a polynomial down to all of its linear and quadratic factors, we know how to solve a linear equation and we know how to solve a quadratic equation. And that will allow us to get all of the rational roots and all of the irrational and the imaginary roots, since we have the quadratic formula and completing the square that we can use for the quadratic factors. But that does mean that in order for us to do this, we have to remember how to solve quadratics. And on the quiz, there was some struggling with that. You guys aren't remembering all of our ways for solving quadratics. So I want you to pause the video, and I want you to solve these 5 by quadratic. And then after you have solved them, start the video again, and you can check your answers. All right. So if you paused like you were supposed to and you solved all of these, you would have actually found that once you got these equal to 0, all of these were factorable quadratics, or in the case of E, a cubic. And so once you got them factored, you should have been able to set those factors equal to 0. We have to make sure that we can solve quadratics. Like I said, whenever we're factoring polynomials, we're going to get them all down to linear and quadratic factors, and so we've got to be able to solve those quadratic factors. All right, so remember factor by grouping. If it has 4 terms or more than 3 terms, we group the first 2, group the second 2, see if we can pull out common factors from those pairs, and if we happen to get the same linear factor or quadratic factor sometimes, we then can pull it up to the front. And again, if we end up with a linear factor and a quadratic factor, set those equal to 0 and solve for x. So here is an example. Let's take a look at what this would look like. So if I group my first 2, and remember, we always want the negative to stay with the number, so I'm going to make this plus the negative so that when I group it, it stays with that number. And when I look at the first 2, it looks like they have x squared in common. So I'm going to undistribute the x squared, and I get x squared times x plus 4. Over here, this first one's negative, so I'm going to pull out a negative factor, and they're both divisible by 2. So I'm going to pull out a negative 2 and put it up front here. So that's going to be a negative 2, and that's going to leave me with x plus 4. And that's important because if I had not pulled out a negative, these 2 would not have turned out to be the same. But they are the same, and so now they're a common factor, and that's what I want to undistribute and pull up to the front. So now I'm going to have x plus 4 as that common factor, and what I'm left with is x squared minus 2. So this is the factored form, and if I'm going to find all of the roots, remember roots, solutions, zeros, x-intercepts, those are all looking for the same numbers. And the way we find those numbers is the same every time. Factor it, and then set the factors equal to 0. That's because we're looking for the zeros. So x plus 4 equals 0, and x squared minus 2 equals 0. That means x is going to equal -4. And then this one, I believe solving this quadratic by square roots is going to be my best bet because I just have an x squared. I don't have an x. So I get x squared is equal to 2, and I can actually take the square root of both sides. But I do have to remember when I take a square root as a tool, I have to remember it is plus or minus the square root of 2. That's how I'm going to get all 3 of those roots. Remember our fundamental theorem of algebra. Whatever the degree is, tells me how many roots that polynomial should have. So this was a cubic. It has a degree of 3, which means I'm supposed to find, if I'm going to find all of the roots, I have to find all 3 of the roots. So for this polynomial, the 3 roots are -4, square root of 2, and negative square root of 2. All right, so I want you to try these two on your own. You're going to pause the video and you're going to work these out. And then after you have worked them out, you'll unpause the video and you can check your answers. All right, hopefully you have finished these 2 problems and you're just checking your answers. So again, I've shown my work up here so that you can look through your work and make sure that if you did make a mistake that you have found your mistake. This one I could factor by grouping. This one I did factor by grouping, but one of my factors I noticed could still be factored. It had a greatest common factor, and I pulled out that greatest common factor, and then it left me with a difference of squares. Guys, if anything can still be factored, remember, we're trying to get it in its most factored form. I'm going to keep factoring it until it can't factor anymore. That's going to make solving those little factors going to be a lot easier the smaller the factor is. And so you want to make sure that you keep factoring. Now, we also talked about the quadratic type functions. And so remember, those are the ones we said that had to be trinomials. They had to have an even degree. So, squared, fourth, sixth, eighth, one of the even degrees. And the middle term had to have an exponent that was half of the degree. So if it was squared, the middle term was x. If it was to the 4th power, the middle term had to be x squared. If it was to the 6th power, the middle term had to be x cubed. If it was to the 8th power, the middle term would have to be x to the 4th. But again, same goal. We have to get it in factored form so we can then solve whatever those linear and quadratic factors are. So if we look at this example, it is 3 terms, 1, 2, 3. It does have an even degree, it's to the 4th power, and the middle term is x squared, which is half of that. So this is a quadratic type, which means I can think of 2 numbers that multiply to equal 36 and add to equal -13. I believe -4 times -9 will do that. So that means that this factors to be x squared minus 4 and x squared minus 9. And then I need to pay attention because both of these can still be factored. It still factors. These are a difference of squares. It's a perfect square minus a perfect square. So that means that this is going to be x plus 2 and x minus 2. And this one is going to factor to be x plus 3 and x minus 3. And so this would be its prime factorization, its factored form. And when we set all of those factors equal to 0, because we want to find all of the roots, I'm going to get x equals -2, x equals +2, x equals -3, and x equals 3. It was to the 4th power, so I was expecting to get 4 roots. and that gave me 4 roots. All right, so again, these are all quartic and they're all quadratic types. I want you to factor them and find all 4 of the roots. Pause your video, do all 3 of them, and then you can start the video again and check your answers. All right, so now you can check your answers. We've got factoring. So we were able to factor all of these using the quadratic type. The middle one did have a common factor. And remember the quadratic tricks that we have for the quadratic types, all of the methods that we use, they don't work unless you take out a common factor first. So I did factor out that common factor of 3, but since there was no x in that common factor, I can't set it equal to 0. It's just 3. It's never going to be 0. It's one of these 2 factors that's going to have to be equal to 0. And it repeated. So don't forget, if we have a repeated factor, that means that that solution has a multiplicity. And so this one was a solution twice, and this one was a solution twice. And so that's how we got all 4 of our factors there. Here we ended up with 2 rational factors and 2 irrational roots. So we got all 4, just 2 rational and 2 irrational. Don't forget our sum and difference of cubes. Now this one's going to be super important because when you have a sum or difference of cubes, you can get the cubed variable by itself and then just solve by taking the cube root. So if I added 8 to both sides and then got x cubed is equal to 8, and then I took the cube root of that, there's only one cube root of 8. That would be 2, and x would be equal to 2. We don't do plus or minus with cube root because the cube root of negative 8 would be negative 2, and the cube root of positive 8 would be positive 2. The problem with this is it's x cubed. I know that it has to have 3 roots, and so if I'm looking for all of the roots, not just the real roots or the rational roots, this only found me 1. So the only way I'm going to find those other 2 roots, which happen to be imaginary, is if I use factoring and I get whatever this quadratic is, because this quadratic is not factorable. I'm going to have to use the quadratic formula or completing the square to figure out what the other 2 roots for this particular cubic is going to be. So knowing how to factor your sum and difference of cubes is vital because it's really the only way that we're going to find those other 2 roots. You're only ever going to be able to find the one real rational root if you just solve for the x by doing the opposite. So let's look at an example. All right. So again, I could just, get x by itself and take the cube root. The only problem with that being it's only going to give me 1 of the roots. And I know I have to have 3 of these roots. So I do notice 8 is a perfect cube. X cubed is a perfect cube. And 1 is a perfect everything. So this is a sum of cubes. So when I take the cube root of 2x cubed, I get 2x. And when I take the cube root of 1, I get 1. So to get my trinomial, I'm going to square 2x. 2x times 2x is 4x squared. Square 1. 1 times 1 is 1. And then I need to multiply the 2. So 2x times 1 is 2x. And then I do my SOAP. So this is going to be the same, plus. This is going to be the opposite of whatever that was, which was minus. And this is always positive. So that's what this factored to be, which means I can now set my factors equal to 0. So 2x plus 1 equals 0 means 2x equals negative 1, which means when I divide by 2, x is equal to negative 1/2. So that gives me 1 of my solutions. But this doesn't factor, and it's not going to. So I'm either going to have to use my quadratic formula or completing the square. I do have a number up front, so I'm going to use the quadratic formula. I really use completing the square only if that number is 1. So if I'm doing the quadratic formula, A is equal to 4, B is equal to -2, and C is equal to 1. So I'm going to do my discriminant first, which is B squared minus 4 times A times C. So that's going to give me 4. A negative times a positive is going to be a negative, and that's going to be -16. So this is going to be -12, which was why this wasn't factorable, because that's going to give me an imaginary number. So the opposite of b would be +2, plus or minus the square root of -12, all over 2 times a, which would be 8. So now we've got some reducing to do. So this is going to be -4 times 3, because I can take the square root of -4. So then I'm going to have 2 plus or minus 2i on the square root of 3, all over 8. And now that I reduced that, pay attention. There's a 2 here, a 2 here, and an 8 here. Those three all have a common factor of 2, which means that this fraction can be reduced. So 2 divided by 2 will be 1. 2 divided by 2 will be 1i. And 8 divided by 2 will be 4. So that's going to be my other two roots. I have x equals -1/2, x equals 1 plus I square root of 3 over 4. And I have x is equal to 1 minus I square root of 3 over 4. So now I was able to find all three roots, not just the rational root. All right, so try this one on your own. Find all three of the roots. Again, pause the video, try it on your own, and then check your answer. All right, so if you used your difference of cubes and get it factored, the rational root turned out to be 5/4. But then this quadratic, again, would not factor. I had to use my quadratic formula. I did need to reduce it, and so I got 20i on the square root of 3. And then these three numbers, -20, 20, and 32, were all divisible by 4. So that would reduce the fraction to -5 plus or minus 5i on the square root of 3 over 8. So again, if I'm finding all of the roots, I had to find 3 of them. I want to make sure that I get all 3.